This is a video of the introduction to square root functions in Desmos. So we'll cover this in class, and then you can look at this video if you need to after class to see the answers to the slides here. So finding patterns, number one, examine the x values in the table. What pattern do you notice? So 0, 1, 4, 9. Those are perfect squares. And two, what do you think the next x value will be and why? So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So the next x value would be 16. Because 4 squared is 16. Okay, and then you'd hit the submit button when you were done with that slide. The next slide is examine the values once again, 0, 1, 4, 9, and they filled in 16 for you, and the output 0, 1, 2, 3. And they want you to find this value for 16. What pattern do you notice in this table? The y values are the square roots of the x values. And what would you predict for 16? So number 2 would be 4. And I think they want you to put that in here. No, it won't go in there. So x values 1, 4, 9, 16. The square root of those are 0, 1, 2, 3. And the square root of 16 is 4. Examine the relationship between the x value and the y values in the table. How do you get from each value to the corresponding y value? We already answered that on the previous slide. What operation do you have to do? So the square root of the x value. And if I type that in the word as y equals the square root of x. We can do the math type here. Y equals there we go. Square root of x. Oh, delete one of those x's. Turn your description to the formula we just did on the previous slide and graph it on the line. On line 1 there, it should pass through the purple points. So you have to come down here again to the keyboard. So y, let's move this out of the way here. Y equals square root of x. And Once you type the correct equation in, then it connects together the points. Change the equation on line 1 so that it passes through the blue point. So if we wanted to move this graph down 3, then we would subtract 3 here. And now that changes the vertex of the square root graph to 0, -3. So we call the end point is what we call that. So we change the end point from 0, 0 to 0, -3 by subtracting 3. That moves the whole graph down 3 units. Why do you think the graph stops on the left side? The domain does not hint the domain does not have negative numbers. Why do you think that is? Because we can't take the square root of a negative number. And change the equation on line 1 so that it passes through the green point. So we're taking the end point here and making it 0, -2. So you can use trial and error here. And this may be a little bit counterintuitive. If I add 2 under the radical, so let me use the keyboard here. So plus, delete that. I got 2 pluses in there now. Plus 2. And, whoop, that's a 1 there. So that's only 1 unit. So plus 1. There we go. So if we want to move the endpoint 1 unit to the left, we add 1 under the radical. So we call that the crazy X situation. So you notice with a Y, up and down, up would be plus, down would be minus. With the X here, it's the opposite. Plus 1 is to the left and -1 would be to the right. So we call that the crazy X. Like, you might not want to talk to your ex-boyfriend or ex-girlfriend because they're crazy. So you might want to kind of think about that when you're looking at what's happening with the X. Left and right is a little counterintuitive there. So if I add 1, then that moves the graph 1 unit to the left. All right, so on slide 8, it says change the equation in line 1 to shift the graph 5 units to the right. So if I add 5 under the radical, subtract 5. So that moves it, the endpoint from 0, 0 to 5, 0. All right, examine X, the X values, the Y1 values, and the Y2 values in the table. How do you get from the X values to the Y values? What operation is occurring? So you can say Y1 is equal to square root of X. And how do you get from the Y1 values to the Y2 values? You add 3. You probably noticed that to get from the x value to the y values, you're taking the square root. Then to get from the y1 to y2 values, you're adding 3. You write a function that does both these operations, the x, in the correct order. So, in other words, y2 is equal to square root of x plus 3. Well, I keep hitting the next button too many times. So now on slide 11, check with a graph. Write your equation from the last slide in line 1. If it is correct, it will pass through all the green points. So y is equal to the square root of x and then plus 3. And that connects all the points together correctly. So if I'm moving up on the y, I'm adding 3 under the radical, or outside the radical. So for y, you're adding or subtracting outside the radical. Up would be plus, and down would be minus for the y value. Examine these values, how to get from the x value to the y1 value again. So y1 equals the square root of x again. And y1 to y2 values, let's see, multiply by 2. Multiply the y1 values by 2. Oops. You probably noticed that to get from the x values to the y values, you're taking the square root again. Then to get from the y1 value to the y2 values, you multiply by 2. Write a function that does both of these operations, the x, in the correct order. So y2 is equal to 2 times the square root of x. And check in the graph here. So using the keyboard, 2 times the square root of x connects the points together correctly. All right, change the equation on the line so that it passes through the green points. So here's the red graph. If I want to go down here, it's a reflection over the x-axis. So in order to change this graph here, just put a negative in front of the 2 here. So let me use the keyboard. All right, and there it goes, connecting the green points together. So to reflect over the x-axis, you just negate the whole function. That's a reflection over the x-axis. Change the equation in line 1 so it passes through the orange points here. So let's see what this does. So if I put a negative under the radical, that's a reflection over the y, so we don't want that. So we want to change this endpoint to -2, 2. So add 2 under the radical and add 2 outside the radical. And then I think we want to flip that. Well, that's -1, 2. So let's change this to a 1. All right. So we moved the endpoint from 0, 0 to -1, 2. I thought this was going like this here. So it was some kind of reflection, but it's not. It's just moving it left 1 and up 2. So add 1 under the radical, add 2 outside the radical. Then match each graph to its corresponding equation. So let's move this over here. So let's look at the ones that don't have any multiplication in them. So this first one here, it's not negating anything. It's just moving the graph right 3 and up 1. So I think that one's this one here. So when it matches up, then the cards will connect together. So that's correct for that one. And then the ones with the negatives in them. So this is right 3, up 2, and then a reflection. So that's over here. So right 3, up 2, and then reflected. Is that one. There, I got to put it on top of there, and there we go. And then now we have to look at the ones with the numbers multiplied. Since this one's a reflection, it's going to be this one here. This one's going down. All right, so that just leaves this one down 5, and then multiplied by a factor of 2 would be this one. And so that leaves that for this. So that's up 1, and then multiplied by a factor of 3, or dilated by a factor of 3. All right, that's it for the introduction to square root functions. I'm going to go ahead and stop this here. And if we don't get through all this in class, then you can watch the video on how to do each problem. So my suggestion is, if we don't get through it in class, watch the video. Well, first do the problems do all the slides on your own, and then watch the video to help you get it all correct. If you make mistakes, go back and correct them, because I'm going to look at kind of each slide for correctness and completeness. So complete the whole activity, and then make sure there's no mistakes in it.